Hi, I'm Dr. Gary Betticher, and in this video we're going to go over the Unit 1 data mining notes, and the title is What is Data Mining? And I've set up these notes more or less using the same format, and what you see in the beginning of the notes is or are the course or the goals for that particular unit. So we'll talk about what is data mining. This is going to lay the foundation for the rest of the course, and we'll talk about what's called the data mining process. And having a well understood, well-defined process is critical to effective data mining. So make sure as you go through the notes to read the goals. Secondly, you'll see in each unit of notes there are objectives. Things like at the end of the unit you'll be able to explain what is a quant, what's the difference between order and chaos, give some real-world examples of data mining. What's the difference between data mining and data querying? Identify different perspectives regarding data mining. What is the, in order, the steps for the data mining process and the significance each phase plays in performing data mining. How we might do some data pre-processing or pre-processing cleaning of data. What are different types of models? What are different categories for a hypothesis? Identify or name 5 out of 10 data mining mistakes, and what are some ethical technical issues related to data mining. And then you'll see any terms here. And the idea is, as you go through the notes, you come back to these objectives, make sure you can answer each of these particular questions. Okay, so I put a lot of time in defining these questions as we go forward. Here's an outline of what we're going to be doing. Well, let's get right into it. Why study data mining? Now, I know for a fact there are many universities that you could attend and many course options, and I'm really appreciative that you decide to enroll in this course. So let me say some things that maybe get you motivated to work even harder in this class. First of all, here's a 2017 salary distribution for data scientists. And so we see the average salary is $91,000. High end's about $130,000, low end $62,000. And of course, it depends where you are city-wise, how much experience, the company and job. But then we see the salary, 60 to 134, any bonus, profit sharing if exists, total pay, so it's 61 to 149. And I think that's a quite attractive salary. Now, Wall Street hires people that are called quants, and they get anywhere from maybe 90 to 157,000. What is a quant? They collect data from a client company, analyze the information, and advise decision makers on financial risk and investments. Typically, a quant holds a master's degree. Now, you might be a quant, might also be a person who develops strategies for making buying and selling decisions in the stock market. In 2012, Rutgers Masters in Quantitative Finance was getting 110 to 120 per year. And here are some salaries for quants I had from 2010. So they can be 640,000 a year, 400-something thousand, 400-something thousand. Blackstone Group is paying 398,000. Well, that's quite a lot of money, but let me put a perspective on it. If you're managing or if a manager of $1 billion hedge fund hires you, and if you could save the company 1%, which is $10 million, well, they'll be glad to pay you, 500,000 of the 10 million. So it does sound like a lot of money, but you're dealing with astronomical numbers there. Well, in Figure 1.2, we see an example of chaos on the left, kind of the universe, and it might have felt like that way with the Hurricane Harvey coming through. And on the right is the UHCL marching band. You probably didn't know we had a marching band, and you might think I photoshopped it, and of course I did, We don't have a marching band, but it looks cool. And so the right photo shows order and the left photo shows chaos. And the question is, what's the difference between order and chaos? Are they related? Do they have anything to do with data mining? And the question is, well, is the universe deterministic? Has everything been determined? Or is it more or less kind of a confused, chaotic state? And I don't have it. My perception is that the universe is probabilistic, that, you know, if you're driving from point A to point B, I might not be able to predict what lane you're in, but I more or less could say, okay, you're going to take I-45 and Bay Area Boulevard, let's say, to come from the airport to UHCL. And what we're trying to do as data miners is to recognize any patterns in terms of the chaos and make order out of those patterns and discover those patterns as we proceed. So we want to kind of move the chaos over to the order side. Here's some examples. One is Amazon real-world examples. You can read those. I won't go into detail. So we have this, Amazon knows what you want before you buy it. Facebook has some voting there article. Now here's an interesting one. You've probably had this happen. You go to Amazon, you look up a book like on data mining, and then what happens? They say things like, if you buy that book instead of $53, if you buy that and then the second book, they give you a price break of $100 and something there. Also, customers who bought this book, and they give a list of other books that the customer bought. And this is an example of data mining where the Amazon goes back over their history and they see where a person has bought book A and B, and so when a future customer comes along and requests book A, they show book B. This is called predictive cross-selling, and it's also known as market basket analysis. So they do data mining to try to put things out there to, make you purchase more than you originally intended. And sometimes what happens, if you see a book, oh, that's an interesting book, you come across something else that you hadn't thought about. Well, what exactly is data mining? Before I talk about that, let me talk about data mining versus database queries. A database query extracts out like a subset, like a certain number of rows or certain number of columns, like a project does columns, and it can do aggregates like average, sum, count. Data mining does not is not part of the original data set. It's based on personal financial information. Is person X a high or low risk for a loan? How many hurricanes, kind of ironic, will hit Houston this year? Very ironic, had that there. A database query provides precise results. Data mining might produce fuzzy results. What are the chances that a person will live to be 90, for example? And database queries, well-defined SQL. In data mining, a lot of tools and techniques, and depending how you use the tools and techniques, you can come up with a variety of answers. So here's an example of a database query. Select star from students where name equals Smith. Select star from students where number of credits enrolled is greater than or equal to 9. Or tuition balance is 0. Well, different people have different perspectives of data mining. And what I've done here, this is the DiningPhilosophers Problem. If you've had operating systems, I'm sure you've seen the problem there. And so we have 5 philosophers sitting around and eating spaghetti because they're all vegetarians. And one philosopher philosopher might say, well, data mining works with data, therefore it must be viewed as a data DBMS perspective. Now, another one would say, well, wait a second, data mining has lots of statistics, therefore it must be viewed from a statistics perspective. Third philosopher might say, well, we're really concerned about performance, so I want to focus on hardware and parallel algorithms. I think that's the most important. And then this philosopher says needs lots of AI machine learning since it tries to find patterns. Well, then the question, which perspective is correct? And there's no real correct or incorrect answer. It's a matter that you can assume one of those different perspectives. We'll be focused more on the AI machine learning perspective in this class. But we'll also look at statistics here and there. So what is data mining? Well, the definition we have, it's an automated process for extracting non-trivial, novel, useful patterns, that's an important word, from a data repository with the goal of helping a knowledge worker better understand his or her environment. One more time, data mining is an automated process of extracting non-trivial, novel, useful patterns from a data repository with the goal of helping a knowledge worker better understand his or her environment. Now, a couple things here. It doesn't have to be automated, might be manual, that's okay. We want to come up with novel patterns, something that is beneficial and that we hadn't seen before. We also want it to be a useful pattern. There was an example, they had an artificial intelligence software, and it was examining accidents that happen around in the home. And so most accidents in the home happen on the first, flight of stairs, on the first stair going up the flight of stairs, and the last stair before you hit the landing on the second floor. Well, the artificial intelligence program said, well, that's easy to solve. Just take out the first step and the last step and you've solved the problem. So that might be a reason, that might be a solution, but it's really not a useful solution. And sometimes some of the tools we use, they produce a model that's very human readable and human understandable. Other times it produces something that we don't understand the model. So it would be nice if the knowledge worker can understand it, but not a requirement. An example might be is you have for example, a neural network which can predict the stock market and make you millions of dollars. And the idea is that you might not understand how it does it, but it just kind of works. Just like when I get on a plane, or if you get on a plane, I don't know all the mechanics of how it works. All I know is it gets me from Houston to New York, or Houston to San Francisco, whatever the case may be. Okay, you can read through that. Well, here's something. Suppose I claimed I have a stock predicting program that can predict tomorrow's final price within 1 cent with 99.3% accuracy. Is this useful, and what might that program be worth? Would it be worth $1,000, $10,000? Well, for you, I'll sell it to you for $5, okay, because you're such a great person. Now, the only thing I forgot to tell you is when I run the program, it takes 2 days to run the program. So it is accurate, but the results when you get it back are not valuable, as you can see. Here's an example of a neural network solution, really messy looking, and here's one of a genetic algorithm. This one is not human understandable, not even human readable. This one is human readable, but not human understandable. So sometimes they produce solutions that don't make much sense, and they may be effective, may not be effective. So we want to be aware of those situations. Okay, I'm going to stop and go to the create a new video starting with the data mining process, so we'll stop right here.